Welcome to GChem classes. So today we are going to see hybridization unit, and as I asked you for the topics, right? Now every day you will tell me the topics, which topic you want me to deal for this upcoming examination IIT-JAM. Okay, so what I'll do, I'll just deal with the important concept and formulas for only for this upcoming examination, and okay, and then based on that some PYQs I'll solve it, and based on that, if you are solving any other questions and if it is not able to solve, you can directly ask me, correct? I'll solve it, okay, and I'll make you understand the things that what is the basic concept behind those questions, correct? So now today we are going to deal with IIT-JAM and topic is hybridization. So after this hybridization topic, whatever questions they have asked and they are going to be asked, it will be easily solved, okay, for you. So now one more thing, after this IIT-JAM, that is on 12 Feb, correct, 12 Feb. So from 13th Feb we are starting one new batch. If you want, you can join it, okay? So it will be like continue 1 year, and this 13th February batch will be for IIT-JAM 2024, correct? So everything will be there, your live classes will be there, doubt session will be there, your unit wise test will be there, correct? Then half length test, full length test, everything will be there, everything will be getting covered by this, and in the affordable price, okay? So let's see today's discussion topic. It is hybridization. So how you are going to deal with this hybridization in your upcoming examination. So one important formula is there. You have to find the steric number. Whatever you want in hybridization, you have to find the steric number, and based on the steric number, we will have the detail, right? So first, what we will do it, just based on steric number, what will be the hybridization, what will be the geometry, we'll see it, okay? In steric number, the hybridization, and then we can say it, the shape or geometry. Okay, so geometry we will talk about geometry. Then shape, just we will eliminate the lone pair, number of lone pair, and then I will say that this is the shape of that molecule, correct? If there is no lone pair, then whatever geometry you are getting, that will be the shape for that molecule, correct? So if steric number is 2, this already I have taken in my previous class, that is in Hindi medium, and it is particularly for one question, correct? So now we are going to deal with for all type of questions based on hybrid, like in hybridization, whatever question they are going to ask, everything will be covered here, correct? So steric number 2, hybridization will be SP and geometry will be linear, okay? If it is 3, it will be SP2 and geometry will be trigonal planar. If it is 4, then it will be SP3 and then the geometry will be tetrahedral. One more thing is that if it is 4, again if it is 4, then it can be DSP2. Okay, in that DSP2 it will be square planar. Square planar, correct? Now again, if steric number is 5, you are getting SP3D. Okay, you are getting SP3D. So if D is your dx2y2, suppose if D is participating dx2y2, then it will be square pyramidal. Okay, if this D is in this sp3D, if this D is participating dz square, then it will be PBP, trigonal bipyramidal, correct? It will be trigonal bipyramidal. So now steric number 6, it will be sp3d2, then this will be octahedral. Here both will participate, dx2y2 and dz2 both. In this, if it is sd5, okay, if only d orbitals are participating, then this will be trigonal prismatic. Trigonal prismatic, correct? Then it will be trigonal prismatic. If suppose if it is 7, okay, so 7 means it will be sp3d3, then it will be pentagonal bipyramidal, okay, pentagonal bipyramidal for d7. Now coming to the steric number 8, if it is steric number 8, then what will happen? sp3d4, correct? sp3d4. So in this d4, what all it will contain? dxy, dyz, dxz, and then if it is taking dz square, then what will happen? If it is last one, if it is taking dz square, If it is dz square, then it will be dodecahedral. Okay. And if it is sp3d4, if the d is containing dxy, dyz, dxz and dx2y2, if dx2y2 if it is containing, then it will be square anti-prismatic. Square anti-prismatic. Then it will, okay. Then it will be square anti-prismatic. This means just you have a look. dz square means when it will be dodecahedral. Just I will take it down here. Dodecahedral means dxy, dxz, dyz and dz square. If it is taking, then it will be dodecahedral. And for square prismatic, square anti-prismatic, what will happen? Square anti-prismatic, instead of dz square, it will be dx2 y2, remaining will be same, right? So this will be square anti-prismatic if it is dx2 y2, correct? So now you can take a screenshot. I will be out of frame. Okay, done. So now what we will do it, we'll just solve based on this number, whatever we have given, like whatever the screen, like steric number and everything is given, the geometry. Based on that, we will solve the PYQs, correct? Because now time is not there for you. Every day one concept you have to revise it, and based on that you have to solve the questions. Because if you have those concepts, then only you can solve it, right? Otherwise it will be like very difficult. You can't mug it up everything in chemistry, correct? Chemistry is interesting when you are just understanding the things. Chemistry is tough when you are starting mugging up the things. So first we will take 2022. So first question itself is like last year they have asked question number 6. You can 6 in 2000. Question number 6 in 2022. It has asked the structure of XeF8 2 minus. So just look into this formula. Don't get confused that what they are asking. They are asking for structure. You can see in the down left hand side. Okay, they are asking the structure. Structure means they are asking shape. Okay, they are not asking geometry, correct? They are asking shape. So how you are going to draw for shape? First you have to calculate the steric number. Just do it. Steric number 1/2. What is the valence electron? So that formula I will write it. Okay, I have not written in my previous slide. So it will be 1/2 V plus M, okay, minus C plus A. And what is the meaning of all these things? Just we will see it. V is number of valence electron. Number of valence electron where the central element. Okay, the central element. Okay, number of valence electron. Number of valence electron. Then M is number of monovalent. Okay, number of monovalent element, right? Number of monovalent. So this is monovalent. Oxygen is divalent. If it is oxygen, we are not going to count there. Okay. If it is fluorine or something where the element is making a single bond, that only we are going to consider here, right? Monovalent. Now see, what is the C? Number of cation. Okay, number of cation overall to the molecule, right? Here we have anion, correct? So we are not going to write that one. So now A. What is A? Number of anion, okay, over the molecule, right? Number of anion over the molecule. Now this is the formula for steric number. Whatever steric number you are getting, just apply to the in your previous slide. The geometry you will get it. And if it is like if it is lone pair, if lone pair is present, then you have to do based on that. Okay, you have to correct it, your shape. How you are going to do it? Just see. For steric number 1/2, the valence electron is xenon. For xenon it will be 8 plus monovalent. How many monovalent are there? 8. How many cation are there? 0. How many anion are there? 2. Okay, so how much it is coming? 1/2, 8, 8, 16, 16 or 2, 18. So how much it is coming? 9. Okay, for 9 steric number we have not seen. So if you want, we can draw it, but it is not required. You just see what is happening. Just you calculate number of lone pair. Number of lone pair is steric number minus number of bond pair. Okay, bond pair. So how much it is coming? Steric number is your 9 minus how many bond pair are there? 8. Correct? 8, because here how many monovalent are there, that many bond pair will be there. So 9 minus 8 equal to 1. So one lone pair is there, so that lone pair you have to deduct it from your this 9. So now overall how much it is coming, it will be coming 8, and for 8 what was there, square anti-prismatic. Okay, it is square anti-prismatic, correct? Likewise you have to solve it. So your correct option will be, you can see in the questions, square anti-prismatic, it will be in option C, right? Option C will be your correct answer for this particular question, right? Cubic, it won't be. Okay, hexagonal bipyramidal also it is not possible. Octagonal is also it is not possible, because 2 minus is there, right? So one electron will be feel as a lone pair, and whatever lone pair here, this lone pair, that we called it stereochemically inactive lone pair. Okay, stereochemically inactive lone pair we call it, correct? So next time if they are asking what is stereochemically inactive lone pair, this is not participating in your either in geometry or in shape. Okay, it won't be participated, because it will be somewhere it will be submerged to the near to the Zenon orbital, right? So it won't expand and it won't disturb your peripheral atomic, like whatever the bonds is there, it won't disturb them, correct? So it is stereochemically inactive lone pair. Okay, if you want to know in detail, because this whatever I am giving, it is just I'm looking your examination, upcoming examination, correct? Based on your upcoming examination. Otherwise, this can't be finished in one lecture, right? It will be like I think more than 5 lectures is required to complete this hybridization chapter, which I am going, I'm crisping and I am giving you in a single lecture, correct? So now the next problem we will take it. I think it is from 2022 only, or let me check. Okay. This was question number 6, and any other questions are there in this year. And tomorrow's topics will be, as I asked already, that what will be the topic for tomorrow's, and so let me see, because one student replied chemical kinetics and one replied that physical chemistry in one shot. So better you just give the name of topic, okay? So it will be easy to discuss the topic, because concept entire physical chemistry in one day, then there will be so many shortcut I have to give, right? And which I don't like to give the shortcuts. Okay, I think only one question they have asked in 2022. There is no other questions. So next year I'll take it. Let's see. It will be 2021. So 2021, one question I'm having. And these questions are very much easy. Okay, whatever easy or tough, we have to make it, right? So question number 13, you can see in 2021, right? Question number 13 from 2021. Hybridization of the central atom in I3 minus, ClF3 and SF4. Okay, they are asking hybridization of the central atoms in I3 minus, ClF3 and SF4 respectively. Okay, so we will just make the hybridization. Okay, find out the hybridization and then we will see the options, correct? For I3 minus, how it will look? I and then I2 and then minus. You have to frame it like this, otherwise you'll get confused which one is the central atom, right? So I2 minus. So now you have to, now you can calculate it. Steric number will be 1/2. How much valence electron for iodine? It will be 7. Plus how many monovalent are there? 2. Okay. And minus how many cations are there? 0. How many anions are there? 1. So likewise you have to put it. Now you see it 1/2 and then 7 plus 2 9 and 1 10. So how much it is coming? 5, and 5 means sp3d. Okay, sp3d. Now what you have to do it? It is your geometry, right? So they have asked structure or geometry. Hybridization of the central atom. Only hybridization they have asked. Nothing to do with this. Like no need to find out the number of lone pair or number, like what is the shape of the molecule. So this hybridization itself is enough. So I3 minus we have done it. Now ClF3 we have to do it. So steric number equal to 1/2. For chlorine it will be 7. and plus how many monovalent are there? 3. There is no cation, no anion, so again it is coming 1/2, 7, 3, it will be 9, no 7, 3, it will be 10, mathematically little bit weak, okay, 2, 5, so it will be 5, then again it is sp3d, correct. Now SF4 we will do it, steric number 1/2, how much for sulfur? It is 6, plus how many monovalent are there? 4, okay, done it. 6 plus 4, it is 10, so 1/2 into 10, so it will be 5, again this will also sp3d. So these are sp3d, 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 okay. So the option number C will be your correct answer, because all are sp3d, sp3d and sp3d. So is there any other questions? This is very much easy, right? So is there any other questions for this year? Okay, after 21 we are going to the 2020. So in 2020 they have asked, just I'll rub the board, you see the questions. Okay, so to 2020 question number 9. The d orbitals involved in the hybridization to form square planar and trigonal bipyramidal. Okay, they are asking for square planar and trigonal bipyramidal. Okay, square planar and trigonal bipyramidal geometries are respectively. Okay, so we have to see in the first slide you have seen that for square planar what hybrid, like which d orbitals they are participating, and for trigonal bipyramidal which orbital d orbital is participating. Okay, so for square planar they will use dx2 y2, you have seen in my previous slide, and for trigonal bipyramidal they will use d z square. Okay, you have seen. Even if it is given square pyramidal, if they are asking square pyramidal, suppose next time they are asking square pyramidal, here also they are taking dx2 y2, correct. So for square pyramidal dx2 y2, because for square planar hybridization should be dsp2, here it will be sp3d, here it will be, this is 3, here it will be sp3d. So in these two sp3d, one will be dz square for tbb, one will be dx2y2 for square pyramidal, okay, and for square planar it will be dx2y2. Why it is square planar? In square planar why it is dx2y2, we will see it. See, this will be the central element. See, these all are in xy plane, right? So x2y2 means how the hybridization, like how the orbitals will look like, this will be look like this, right? It will be on the axis, correct, x and y axis. So that's why the square planar will be in the on the axis, and because of that dx2y2 we have in square planar, correct. So this is one more. Let's see, is there any other questions are there or not. Okay, one more question is there. Let me solve this from the current year. The current year which I am discussing now, this is 2020. Question number 16. Okay, question number 16. The geometries, they have asked geometries. I'll just write it down here. Geometries they are asking. Okay, geometries of BR3 plus BR3 minus and BR F3 are respectively. See, whenever this type of question they will give, just find out the central element. Okay, so how you are going to find out for this BR3, how you are going to write BR and then BR2, and here you put positive. For this molecule, what you are going to write? First we will solve it this one. So for steric number, how much it is coming? 1/2. Here will come valence electron 7 plus monovalent 2 monovalent is there. How many cations are there? 1. So 1 cation. Okay, cation is minus always. So how much it is coming? 1/2 into 7 plus 2, 9. 1 deducted. So how much it is coming? 8. 4. 4 means it will be sp3. Correct? Now coming to the sp3, we can write it tetrahedral. Well, for Br3, how we are going to write it? Br and then Br2 minus. Just find it out. Steric number 1/2, 7 and plus 2 monovalent plus 1 because cation we are adding up. So 1/2, 7 to 9 and 10. Okay. So how much it is coming? 5. 5 means sp3d. So it will be TBP. Okay. Geometry will be TBP. Now third one we will see BRF3, right? So BRF3. So for this BRF3, how much it is coming? Steric number equal to 1/2. How much valence electron? It is 7 and plus what is the monovalent? It is 3. Okay. So how much it is coming? 1/2 into 10. So it will be 5 and then for 5 it is sp3d and sp3d means what will be the geometry? It will be TBP. Okay. So these are the questions they have asked in your previous year examination. I think is there any more questions are there? No. Right. Wait. I'll check it. Is there anything? I'll solve it. Otherwise, if you are finding any other questions from the PYQs, you can ask me. Or if it is not in PYQ, if any further hybridization which you are not able to solve it, you can directly ask me in my WhatsApp. I'll solve it. Correct. So based on that concept, whatever concept you have learned today, I think it is enough for your upcoming examination, and you can solve it. Okay. So, and if you're willing to join the new batch for IIT-JAM 2024, you are very much welcome, and you can join it. It will start from 13th February. Okay, it will start from 13th February, and we will learn together chemistry, and hope everything will be fine for your upcoming examination. So, thank you very much.